Hello students, Namaskar. The topic that we are taking right now is normal form of the equation of a line. Before we begin, first you need to understand what is normal to a line. Dear students, normal to a line is the perpendicular drawn from origin to a line. Once again, I am speaking. The normal to a line in Cartesian plane or two-dimensional plane is the perpendicular drawn from origin to a line. You may note it down. I won't repeat the definition of normal to a line. Here, in the normal form of the equation of a line, in order to find this, we will be given two things. The first, the length of normal, and the second, the angle made by the normal with the positive direction of x-axis. So, let us start the normal form of the equation of a line. The normal form of the equation of a line. Dear students, as I have just now spoken that we will be given two things. Here I am mentioning, consider a line L such that the first given thing, the length of its normal is P, and the second thing, the angle made by the normal with the positive direction of x-axis is omega. So, what two things we are given? Length of normal as P and the angle made by the normal with the positive direction of x-axis is omega. Dear students, I am drawing a line in the Cartesian plane. Let this be the Cartesian plane with x-axis and this is y-axis. Origin, let this be a line L. So, when we draw the normal to this line, that is perpendicular drawn from origin to the line, let this be the normal to the line. So, let OA be the normal to the line or A be the foot of the perpendicular from origin. So, now the line may be drawn in any form in this Cartesian plane. The angle made by the normal with the positive direction of x-axis may be from 0 degree to 360 degree. As if I draw a line over here, the normal will be obviously this and the angle made by the normal with the positive direction of x-axis will be more than 270 and less than 360. So, the angle you can say the range of omega is, omega can be greater than or equal to 0 and less than or equal to 360 degree. This you need to keep in your mind. Later we will discuss it more. The reason I explained you, as I am taking only one case, I am not explaining you the different cases, or only in this case I will explain. So, first of all, to begin, I will get the coordinates of this foot of the perpendicular or the coordinates of the point where the normal meets the line. As it is given, the length of normal is P, hence the coordinates of point A are P cos omega, P sin omega, as this particular angle is omega. how the coordinates of point A are these. For this I may refer the trigonometric functions, where if you remember, if there is a circle, the coordinates of any point on a circle are of this particular form: r cos theta, r sin theta. Okay, where r is the radius of the circle and theta is the angle between x-axis and this particular line segment from origin to the point. So I hope you have got it. Now, using these 2 points, we will be getting the slope of normal to the line. You can write the slope of normal OA is, what will be the slope of, as there are 2 points on the normal, here 0 0 and the second one is this one. So by 2 points form of the slope, you can get the slope of this particular normal: y2 minus y1 0 and x2 minus x1 0. So p sin omega over p cos omega. So p sin omega minus 0 over p cos omega minus 0. P is cancelled by p and we have got tan omega as the slope of the normal. Hence, therefore, the slope of the line L is equal to minus 1 upon tan omega, as both are perpendicular to each other. Now, dear students, we have 2 things about this particular line. The first one, we have got the slope of the line as this, and the second one, we have a point on the line. So if we are given 2 things, a point on the line and slope of the line, we can use point slope form of the equation of a line. So here, using by the point slope form, equation of L, what will be the equation of L? Y minus y1 is equal to m times x minus x1, implies that y minus y1, the y coordinate of the point that is lying on the line, p sin omega, p sin omega is equal to m, the slope of the line, that is minus cot omega. Minus 1 upon tan omega means minus cot omega. X minus x1, x coordinate of the point line on the line, p cos omega. Now, if we simplify this, we get y minus p sin omega is equal to, this can be written as minus cos omega over sin omega times x minus p cos omega. By cross multiplication, we get sin omega, y sin omega minus p sin squared omega is equal to minus x cos omega and minus minus plus p cos squared omega, implies that, get this term this side, x cos omega plus y sin omega is equal to, get this term that side, we get p common and sin squared omega plus cos squared omega, and that is equal to 1. So what is the normal form of equation of the line? The normal form of the equation of the line here I am mentioning is x cos omega plus y sin omega is equal to p. is the normal form of the equation of a line. Keep always in your mind, x cos omega plus y sin omega is equal to p is the normal form of equation of a line, where omega is the angle made by the normal with the positive direction of x-axis and p is the length of normal. So that's how we have got the normal form of equation of a line. If we quickly take an example now, very simple example so that you can understand. Example is, find the equation of a line such that its normal is of length 5 units and makes an angle of 30 degree with the positive direction of x-axis. Positive, I can quickly write direction of x-axis. That is the question. So what we are given, students, we are given the length of normal is equal to 5 units and normal makes an angle of 30 degree with the positive direction of x-axis. So you may write in the solution that here P is equal to 5 units and omega is equal to 30 degree. These two things are given. Therefore, by normal form, equation of the line is x cos omega plus y sin omega is equal to p. Let's substitute the values of omega and p. The value of omega is equal to 30 degrees. So x cos 30 plus y sin 30 is equal to p, the length of normal, that is equal to 5 units. Implies that x times the value of cos 30 degree under root 3 upon 2 plus y times the value of sin 30 degree 1 upon 2 is equal to 5, and on simplifying we get under root 3x plus y is equal to 10 is the equation of the line. How have we got? By using the normal form of the equation of a line. So we have formed the normal form of equation of a line and took an example on the basis of normal form. Thank you.